Morning, I'm Mike Mueller. I'm at Cambridge Engineering, and we're going to be reviewing a CS800 heater with a PLC-based control system for the process heating industry. This is our first PLC that we've used to run one of our heating systems. This PLC has been programmed with 3 different modes. Within ventilation mode, you can see that the supply air fan is on. Our burner system is off, and there are auxiliary contacts within the control box that can turn on an exhaust fan or a disturbance fan or some other device within the room. This fan signifies that output is on. Our second mode of operation is comfort heating mode. And here, this is very similar to a home thermostat. You can set the room temperature right here. There you can see the set point is 99 degrees. You can see the supply air system is on. The burner is on for the system, and the ventilation, the exhaust, is also on. Here you can see the actual temperature of the room. This is reading 85 degrees right now, and the PLC is outputting 100% power to drive the temperature of the room up to 99 degrees. As the heating system approaches the set point, the control system will back off the percentage of power. There's also a PID loop included in this control system so that you can fine-tune the system in order to not overshoot the temperature. Our last mode of operation is process heating mode. And in this mode, we get to set the operating parameters of the oven. It's basically a controllable, programmable oven. I'll turn the system on. And there's a time delay that allows our heating systems to ignite. I believe the delay is about 20 seconds. After 20 seconds, the PLC will take control of our heating system and go through a predefined program. This program will take the set point of the room and increase it by 9 degrees every hour until it reaches 150 degrees. Actually, that's every 30 minutes as we have it programmed here. And then once it gets to 150 degrees, it'll decrease 9 degrees an hour, and it'll end the program at 95 degrees. That's why we have a heating section and a cooling section. The current set point is 95 degrees. The current room temperature is 87 degrees. It's outputting 100% until it gets to 95 degrees, at which point it'll stabilize for the remainder of that time sequence. Within the program, there are definable variables. Those variables are keyed off of these buttons. We have the heating setup, where we can input the increment value of how many degrees each step will increase. We've got a PID setup where we have the PID settings, the PID and S settings for PID control, typical in HVAC systems. We have a timing setup. There's an initial, in the process and in comfort heating modes, there's an initial 30-second delay that allows our heater to go through the ignition cycle prior to the PLC taking control. You can set that time up here. Obviously, we've got password protection, and here we are back to our input screen. I have to wait the 30 seconds until it allows me to jump out of the screen there. So. PLC control system for our CS800 and CS1200. First of all, we have a power shutoff. This kills power not only to the heating system but also the PLC control system. Here we have some heater lights. Whenever power is on, obviously the power switch, the power light will be on. Depending on what mode it is in, the airflow sensor will kick on once we turn the system in ventilation mode, comfort mode, or process heating mode. Once the fan starts to turn, it'll turn on the airflow switch. This is the burner ignition. So in comfort heating mode, get that to turn on. Comfort heating mode, and in process mode, when the burner is on, this red light will come on. In the event that we have outdoor air coming into the system and the burner fails to ignite, the system will run for 1 minute and then this light will come on, and that is so that you don't freeze your room if the outside air conditions are below freezing. We're running on natural gas, and this is a potentiometer that controls our variable speed drive on our fan. You can hear it going down. It runs from approximately 2,000 CFM to 3,000 CFM. The fan within this system is a backward inclined wheel that's capable of static pressures up to 3 inches. Below we have 2 buttons. Right now they're both on the thermostat, which means that the PLC is controlling the heater operation. We can put these in local mode, blower and burner, and the system will run without the PLC. This is mainly used for troubleshooting of the HVAC equipment. And that's all.